Hello everyone, I'm Suresh Mathew, founder and CEO of Sedai. Today I'm going to answer one question. Can we build a self-driving cloud? You know better than anyone how difficult is it to manage a multi-cloud environment. Endless containers, VMs, serverless tasks, network, and they all require constant attention. But that's changing. We see a massive shift in how companies manage their cloud. A real quick bio on me. I've been working with cloud for the past 20 years. I've seen the challenges of platform engineering firsthand at Oracle, Nokia, and PayPal. I founded Sedai because I knew platform engineering needed machine learning. I believe that platform engineering is about exciting projects, not just about endless busy work. The good news is world's most coolest companies are already making that shift. You need to just fundamentally change the way you manage the cloud. I know this because I built this technology and I meet with these companies on a daily basis. And these companies are using AI to manage their cloud, optimize it, and run it even in complex environments. At the end of this presentation, you will be ready to lead your company into the next evolution of the cloud. The promise of the cloud was revolutionary: efficiency, simplicity, scale. We will handle hardware, you focus on innovation. Cloud would reduce cost, it would eliminate complexity. But today, most companies are struggling more than ever with the same issues. Our costs are skyrocketing, complexity is unmanageable. This is an unmanageable situation. Automation seemed like the logical solution to the problem. Here is an example of a simple autoscaler. Target CPU and target memory, the threshold at which an engineer should expect their application to scale up or out. This number is unknown to an engineer. Being an engineer, I know that I know how to code, but I do not know what is the right CPU in number for my application. So, this is where I always go defensive. When I ask a number, I'll give a number that will avoid a production incident. And eventually, that will waste a lot of resources. So, if you look deeper at the problem, it is the root cause is really automation. Wastage is because we are automating things and asking a lot of questions that engineers have to answer. And they answer in a smart way and avoid incidents where they can avoid incidents. Unfortunately, doing nothing is also not the answer. You can hire an army of platform engineers and still have a critical production issue. In general, when you have a lot of permutation combination and a lot of releases in play, doing or configuring it manually becomes extremely hard and risky for any cloud. So by now, we know that both options we tried or we learned is not working. One, automating it, that exactly is the root cause. The configurations, the automated configurations are the root cause of wastage. The second option, hiring a lot more or throwing people at the problem, is quite risky. They'll end up having wrong configurations or have very defensive configurations that will waste a lot of money. So, in other words, your cloud is already driving in million different directions and no one is at the wheel. So, what exactly is a self driving cloud? And the most important question, can I trust it? The essence of self driving is safety. Let's, if you think about a self driving car, right, if a biker veers off of his lane into our lane, will we be able to automate it so there is a rule to avoid that scenario? This if then else So options are not going to work in these cases, especially in a cloud when your applications are sensitive to a lot of things and it's constantly changing. You need a system that deeply understands your app, right? We use deep RL to understand it, and we have patterns to make sure that we are not causing an incident ever. So the key to a self-driving system is safety. That's the only thing. If you look for one attribute of a self-driving anything is safety. It will never cause an accident or an incident. Self-driving cloud is the safest way to manage your cloud. It works because it relies on what engineers and AI each do well. Engineers set the goals, set the directions. They decide if you take an analogy, if you go from place A to place B, the goal, the destination is always configured by the engineer. They configure where to go. They also tell you what routes to avoid, what conditions to avoid. Now the goal is set. Now AI kicks in. It takes it from there. AI decides on how to get there. The good thing is your engineer set the guardrails and you have now an AI that works according to it. Now we are going to discuss a few myths here. The first one, we are not ready for ML. Our cloud is not mature enough that we can adopt an ML technology to drive my cloud. This is a big myth. AI knows where to act and where not to. So if it sees an application that has needs a manual intervention, it knows how to back off. So any cloud is a good surface for AI to operate. Moreover, you have right now automation managing that cloud, which means you're already running a risky environment and it can only get better with AI. And the second aspect is generally when ML comes in, we think that it can replace people. As I mentioned in my previous slide, the goal is always set by your engineers. They understand the applications and the environment really well. What we or a self-driving cloud tries to understand is how can I learn these applications a lot better so I understand what this engineer needs now. I know the goals. Now I know your applications. I know the traffic that's coming in. Now I know how this application is going to respond to the changes that I'm going to make. That's where the reinforcement learning kicks in. So whenever you're building a self-driving cloud, you're always thinking of how to make this change and assume that there is no one else at the wheel, right? So you look for all the changes that you can make and you can be confident that this will never be a mistake because you have either seen in the past or you have your RL telling you that you can do it. Over the last few years, we have expanded the range of self-driving cloud. 90% of the compute related systems in all three clouds can be managed autonomously without manual intervention. That includes Kubernetes, ECS, serverless, VMs, and things of that nature. Now, data platforms, we started covering that as well. So you can see that data platforms and compute can be now managed by a self-driving system. Data platforms like Databricks and EMR, things of that nature, are also slowly getting autonomously managed. When you do all these things, keep in mind that you're almost taking all the actions that a human would take, which means now you have to almost act like one. So you have to file the ticket, you have to make sure that you can write code as well. When you make a change, there could be some implications of the code as well. So you have to write those changes and send it back as a PR. So it has to be a full loop where you're observing the system, you're learning it, you are deep learning it, you're making changes. Changes are sent back to your GitHub, and that's how the system operates. So the real question is, what does this technology mean for you? Why does it matter? The key here is you have to be a leader who can bring the next era of technology for your company. And that's what this technology enables you. This will help you expose your company to this new AI way of managing your cloud, the safest way to manage your cloud. So that is what this presentation is all about. How can you build an autonomous system? How can you build a self-driving cloud within your company? I'm going to show you three critical numbers. In fact, there are four. I'll talk about the fourth number, but I'll show you three. The first one is average productivity. So, this is the amount of valuable engineering hours that an enterprise would save with an autonomous system, an average. And this can be, of course, repurposed for building a new project, a feature, and engineers can enjoy that process too. And this is the average annual savings, and it's dollars, so you can repurpose it for anything. And this is the most critical number. There are 25 million autonomous actions performed by our system, which means there is a real use case of an autonomous system making changes. So you save money, hard cloud dollars, you save your cloud from incidents, you save productivity hours for your company. And the fourth number is the latency that you save. Most of these changes would also help run your applications faster. So it's all about making your cloud a lot better with an autonomous system, a system that deeply understands your application, figures out what exactly are the levers that I can change so your application runs faster and cheaper and better and more available. All of this technology is ultimately about us as engineers, as people. How can we shift our focus from routine work to passion work? That is the real power of self driving cloud. Thank you.